Hey guys, this container contains tungsten hexafluoride, the heaviest gas in the world. Now I let it out. Upon contact with the moisture contained in the air, tungsten hexafluoride begins to quickly hydrolyze, forming a fog consisting of hydrogen fluoride and tungsten oxyfluorides. Due to the formation of hydrogen fluoride, this heavy gas has a destructive effect on many organic materials containing moisture. So flowers literally melt upon contact with tungsten hexafluoride. These shots I made for everyone who doesn't like arugula. All green vegetation turns yellow upon contact with tungsten hexafluoride, and with prolonged exposure, it begins to completely dissolve in the resulting hydrofluoric acid. My dry and brittle hair does not contain moisture, so the interaction with tungsten hexafluoride passes without a trace for it. However, it reacts when I add a few drops of water. Therefore, it's better not to get into the atmosphere of tungsten hexafluoride with a wet head. Look at this. This is a mirror-polished wafer of extra-pure silicon. In industry, this gas is used to produce extra-pure tungsten. To avoid unnecessary impurities, tungsten hexafluoride stream is directed at hot silicon in a vacuum, depositing tungsten on the silicon surface. I'll heat this plate with a gas burner, and when it begins to barely turn red, I'll apply a stream of tungsten hexafluoride. Look at these tiny particles with a metallic sheen. This is tungsten that we got from the gas. If I direct a stream of fire at them, they will turn into yellow tungsten trioxide. Here, in a quartz tube, I'll simply heat a mixture of tungsten hexafluoride with hydrogen. As a result of this reaction, a pure tungsten mirror should be obtained. So now I turn on the flow of hydrogen. Bringing an open flame to the tip of the tube, you can see how hydrogen burns. Now I turn on the current of tungsten hexafluoride and strongly heat only a small part of the quartz tube with my butane torch. It's in this heated section above 500 degrees Celsius that pure tungsten begins to precipitate, forming a layer of metallic mirror. Tungsten has a very high density, comparable to gold. This is why tungsten hexafluoride is so heavy, you can literally pour it out of a glass. You'll know the famous experiment with an aluminum boat that floats in an aquarium with sulfur hexafluoride. But will the same effect occur with tungsten hexafluoride? So, this glass box is completely filled with tungsten hexafluoride. Some of it reacted with air moisture, but there is still a significant amount. I'll try to lower 3 boats made of aluminum foil there. Very unexpected. I thought the boat would float on the surface, but it only hovered for a moment before sinking to the bottom. Perhaps the concentration of tungsten hexafluoride was not sufficient. Share your thoughts in the comments on why this happened. After being in an atmosphere of tungsten hexafluoride, aluminum boats turned blue due to the formation of tungsten blue. Compounds of pentavalent tungsten, like pentavalent molybdenum, have a pronounced blue tint. Look, if we apply a stream of tungsten hexafluoride to aluminum foil, as a result of the reaction, part of the hexavalent tungsten will be reduced to pentavalent, and the aluminum foil will turn blue. This reaction is only possible in humid air. By the way, the walls of the glass box were forever damaged by hydrogen fluoride formed in the reaction. So, to check how my voice will sound in atmosphere of tungsten hexafluoride, I hidden this wireless speaker and dive to the bottom of a glass box that will be filled with the heaviest gas. Oh, I can hear this room filling with something sinister. It's good that I'm safely protected from this poisonous fog and can continue to talk to you. If not for this protective suit, then this gas would have done to my lungs what it did to arugula. By the way, I love arugula very much, do you? Check, check, mic check. 1, 2, 3, 5. Well, I confess to you, in fact I didn't hide in this Bluetooth speaker, I just recorded my voice in advance, so I don't know how my voice sounds now, but I'll try to laugh devilishly. Your soul is mine. Ha ha ha! As a result, my voice from the speaker didn't change at all. I didn't hear any changes, but the appearance of the Bluetooth speaker changed. It turned blue and stopped working the next day. Now let's fill the balloon with the heaviest gas. The same balloon inflated with air with a volume of approximately 1 liter should weigh 1 gram more, but these scales are not so sensitive and still show a value of 3 grams. Now let's fill the balloon with approximately the same volume of tungsten hexafluoride. Wow, look, as much as 14 grams! Tungsten hexafluoride is approximately 10 times heavier than air. Now I'll fill up both of these balloons. This is how an ordinary balloon jumps. And here is a ball with heavy gas. Latex is not resistant to the action of tungsten hexafluoride. When the balloon is inflated, its walls stretch and become thinner, making it impossible to fill a large volume of tungsten hexafluoride into a regular balloon, as it will burst quickly. However, special foil balloons can retain this gas for several hours. Let's fill one such balloon with heavy gas and go to the field to play ball.
Thanks for watching, everyone! I hope you enjoyed this video, which focused on the physical properties of tungsten hexafluoride. In one of my upcoming videos, I'll explore the various chemical reactions involving this substance. Make sure to subscribe to the channel so you don't miss it. Of course, I want to express my gratitude to my patrons. Their support helps me offset some of the costs associated with producing this expensive chemical content. If you have the opportunity to contribute, consider becoming a patron of the channel. All links are in the description. So don't forget to like the video and I'll go prepare a new one for you.